case you're looking for the right talk, this is open source instead of outsource your database. Is that audio better? On my ear, still can't hear me. Talk up more? Okay, cool. Cool. Open source instead of outsource your database. Thanks for coming to this talk. I think it's an interesting subject, of course, and I wanted to kind of share that with you today. So you've probably seen my face around. Brandon, you can follow me on Twitter at Brandon T. Roberts. I have fun on Twitter. I talk about sports. I block people sometimes, but it's just what I do. So give me a follow there, and I share a lot of stuff on there, a lot of fun stuff. So I'm also a maintainer of the NGRX project, which is a set of open source libraries for Angular. They help you build reactive Angular applications. So if Angular is your thing, or if you've tried it before, feel free to check that out. Also a Google developer expert, which just means I've been around the community for a while, been able to do some cool things there, so you get some recognition for community work and continuing to do that. I am also an engineer at OpenSauce. OpenSauce is relatively new, but open source is not new, so we're just kind of continuing that ecosystem to go forward. You can check out the site at opensauce.pizza to see how you can find your next open source contribution and kind of get a little more feel of what we're going into there. So yeah, for the agenda for this talk, I'm going to talk about like choosing your stack, talk about building the products and potential stacks that you would have in that area. I'll talk about outsourcing your database versus the choices that you make for outsourcing your database, or if you go with an open source route, and also talk about REST APIs and kind of the essentials for building those, and also talk about AppWrite, which is, of course, an open source project, because I'm all about the open source, as you can see by the shirt, too. So first, I'll talk about choosing your stack, and choosing your stack about what kind of building products and that the choices that you kind of have to make there. So, of course, with the product that you want to make yourself, you have to think about what type of product it is or thing that you want to build, whether it be a front end or a web app, a mobile app. And I'm kind of going to go through like different types of applications, of course, different areas that you may focus on. Mobile development is always a choice, and you have a couple of different types there. Also backend development, where you kind of develop services for other apps to consume. And so those are just a few areas that you can build there. And then we'll get into front-end applications, because of course there are plenty of choices to build front-end applications. Most of these are modern web frameworks that you may be used to. Some of them I'll mention here, but it's not a complete list. But some of these are some of the more popular ones today. I already mentioned Angular, because that's kind of the space that I've been in for a while. There's also React, Vue, Svelte. There's also other server-side frameworks, or even meta frameworks that are out there that you can use to build web apps. So for mobile applications, there are many choices there also, whether it be native development. If we're looking at Android, Android uses Java, or most recently uses Kotlin to develop apps with. So for iOS, there is Swift, which is, I guess, becoming more popular, and also Objective-C, just as another language choice. And building mobile apps, you also have hybrid options there. If you want to build something that's kind of web-based, that lets you use your existing web technologies to extend that to building mobile apps. They have hybrid applications. A few of the choices that you can have here in terms of Flutter, which is something that's produced by Google, which is still an open source project. Also Ionic, which is powered by web technologies and considered to be, or they call them web native applications, to kind of bridge that gap between web and mobile. And there's other options like NativeScript, which these do similar things where they're taking web tech and kind of bridging that gap with native APIs to help you build these that functionality there. You can also build standalone web apps, such as PWAs or progressive web applications, to where they kind of, as the browser allows, they allow you to enhance the web application that you're already building, depending, add more features and functionality there that you would normally get on the native side, extending more of that to the web. And of course, there are other ones that I haven't mentioned here. If we look at desktop applications, look at the .NET framework, which of course has been around for an extremely long time, built by Microsoft. Look at Electron, which is used to build lots of desktop applications using web technologies. Or if you've been around the industry for a while, you may be looking at Java to build applications with, because it's been around a long time. And even, as I mentioned before, for Ionic, for hybrid applications, you can also use it for desktop applications. And React Native also is another option that you can choose, especially if you're comfortable with the React ecosystem and want to extend that to build other types of apps. I'll keep looking at this. For backend applications, I know I'm going through a long list here, but there's I just kind of want to paint a picture of some of the choices that you have when you're, depending on what type of product you use. And then we'll kind of get into the database side of things. But for backend frameworks, there's Node, there's Express, which is kind of a pretty low-level library that you may or may not be comfortable with for routing in Node.js. There's also Fastify, which is another low-overhead framework that's inspired by Express. And then there's more modern ones like Nest.js, which has support for Express and Fastify. And of course, there are other, if you want to build like these or command line applications, even with .NET or C#, you can also do that too. So if we just continuing with backend frameworks, if PHP is still around, I used to be a backend developer, so I got to give some shout out to PHP there. Laravel is, whenever I think of, okay, I'm going to digress here. Laravel has messed me up because every time I think of Laravel, I think of Lamborghinis because of Taylor Otwell. He posted a picture of, he said, thanks PHP, and he had a Lambo in his tweet. So I'll digress there really quickly. But Laravel's out there. There are other options like Symfony, CodeIgniter for PHP applications. And for Python, if you're used to building backends with Python, there's Django and Flask, and I'm sure there are other options there, but these are the ones that I've become more familiar with over time there. So, and for .NET Core, as I mentioned, there's ASP and C# options there. So then we get closer to where we're headed with this talk. And last but not least, databases. There's MySQL, which is one of the oldest open source database projects. And there's also MariaDB, which I'll kind of get into further in terms of AppWrite. That was a kind of a spin-off of MySQL because it got acquired by a larger company and it kind of wanted to retain the origin of what MySQL stood for. There's also MongoDB, which is a NoSQL database that you can use for that. Postgres, which is another relational database, open source. Others like CockroachDB, and like I said, the list goes on there. I listed all those to say there are just a lot of options and stacks that you want to choose to get an idea off the ground. But the good news is, like I said, if not all of these, most of these options are open source, not source, open source. So there's no shortage of choices to be able to use freely that you can take and build, things that make money for you in that way. So going back to the database side of things, Professor said there's a choice on why you would outsource your database and your data compared to self-hosting or rolling your own solution. And as I mentioned, of course, there are many open source options available, and because not everyone wants to be in one camp or the other, where they want to give their data over to someone else or self-host on their own infrastructure. So let's look at some of the things on deciding when to go with open source, go with outsourcing your data to a third-party provider versus directly using the open source solution and running it on your own infrastructure there. And I'll talk about some of the pros of each approach for outsourcing versus open sourcing and the cons there. There are some decision factors decision factors that come into place on choosing where to host your data. One of them is time to build. There are solutions out there that let you be able to start working quickly. They give you a lot of these tools out of the box, and that's one decision that you have to make when deciding what do you want to build and how long it's going to take to do that. There's also resources, and this, like I said, this could be many different things that factor into which type of solution that you go with. There's also team size. If you have a small team, you may not want to invest in kind of rolling your own from scratch. You may want something that can get you moving quicker. And also custom business logic or custom requirements that factor into what you want to choose as far as something off the shelf or something that you want to tailor extremely a lot. Also, other decision factors could be regulations. There could be strict regulations in what providers you can choose. In some countries, they prefer you to choose open source solutions versus outsourced solutions just for data ownership and not they don't want you to host your data or things like that in like foreign countries. Outside of there, they want to kind of keep that really close to the vest. Also ownership. If your company really touts data ownership and mobility, this is probably a very important factor in choosing which solution that you go with. Also, privacy and privacy laws. Like I said, some countries have laws in place that if you have a choice between third party or hosting it yourself, then they kind of want to lean you in that direction. Of course, this is maybe more so in like government sectors where they want to have more control over where that data is and where that data goes. And last but not least is money, which of course money gives you more resources, gives you more access, and if you have the people who have the knowledge there to be able, like I said, build on top of that or hire more people, and you may not need to use a third-party provider there. So let's talk about outsourcing your data, and I kind of get into what that means as far as outsourcing your database or outsourcing your database and data, some of the pros to this approach and the cons also. So outsourcing, what does that mean? At a basic level, it just means that you choose a provider that you don't have primary control over. It could mean that provider even could use open source software, but the product itself is closed source because you don't have access to see everything that the company's doing with that source code. They may have some custom things built on top of that, and this is pretty standard in most cases because open source is beneath a lot of the infrastructure that we use already. So this usually also means hosted access, where they host the servers and they host your data, and you're making that trade-off of them having to manage those things and keep that data safe there. It's also privileged access because you don't necessarily know what else is running on those servers or what else they're doing with that data, because you're kind of handing those keys over there. So some of the pros to outsourcing outsourcing your database to this approach. is ramp up time. As I mentioned, there may be significant ramp up time for development to allow you to move faster than you would having to roll your own infrastructure from scratch. These are also owned by large companies that have a lot more money and may have a lot more money, a lot more resources that have already done this before. So they have something out of the box that they can provide you just already kind of tested there. There's also the amount of scale that a company can provide. If you're choosing something that you host yourself, then you're creating your own scale for the needs of your company. But these companies have kind of built these solutions to scale up already. And there's abstractions that are key to integrate with your stack of choice, whether it be, like I said, web, mobile, or other there. And one thing is also managed data. Because someone else is hosting it, they're managing the servers, they're doing upgrades, they're doing these things to alleviate those aspects from your workflow that you don't have to do in addition to building the product or solution that you're trying to build. So there are some potential cons with this approach. Just as a pro, this could be a con where they're owned by large companies, and you may not get the kind of adequate support that you need when you're a small fish in a big pond of other companies that are kind of using that service also. It's also harder to pivot, kind of due to vendor lock-in. Once you had a lot of data, you've stored a lot of data there, you want to, maybe you figure that it's not as cost effective anymore to use that service, but once you've invested a lot in it, sometimes it's hard to pivot there. There's also another area is cost, where you have to pay more towards a certain tier of usage for that particular service. And if the price goes up, then, like I said, you may be back at the point where you want to pivot, but cost definitely factors in there. And there's also, with these abstractions that I mentioned before, there's also the tribal knowledge to where you can't easily transfer like the knowledge of that provider to another place if needed, because they have, like I said, they have their own SDKs or a certain way of doing things. You also lose some ownership of that data. You can get access to that data through the SDKs. They may have some way to look at, tables and things depending on what you're hosting there. And security is always a concern. Like I said, as the code is behind closed doors, and there may be vulnerabilities there that you just don't know about. And then you're kind of on the other side of that, where something happens to the company, data gets breached or something like that. So things to consider. So now let's look at this from the open source angle of these approaches. And just like we talked about outsourcing with open source, what does it actually mean if you're not that familiar with contributing to open source or how open source projects are used in general? Or maybe you're just used to consuming them and using them in that way. So we talk about pros for this approach and cons also, because there are trade-offs in either scenario, so you have to kind of make that decision. So open source, it just means it's openly available to use. People have invested time and resources into creating this software, based on an idea or a vision that they have. So it's also openly available to modify. Open source has licenses to where you can freely take that source code, modify it to your own needs. As I mentioned with closed source solutions, a lot of them are built on top of open source projects that exist already. And there's no shortage of existing solutions or implementations that you can take advantage of in open source. Like I mentioned, web frameworks, take your pick. It depends on what type of thing you're trying to build, or even what you're more comfortable with. There are many different types you can choose there. And some are self-hosted or managed, where you can take that open source project, like I said, run it on your own infrastructure, or they may have a service also that is managed that you can take advantage of, whether that service is free. Some of them freely, let you use that up until a certain point. And there's community around those particular projects for open source. So some of the pros is that it's, like I said, available. It's available for you to run, use, modify. Available for you to have more ownership of that. If you're using, like I said, open source database, you know how, if you're willing to dig down in the weeds, you can see how everything works. You have ownership just of that data, just like the source code. It's secure in that it's been vetted by many other developers and companies that are using that solution or database. So there are a lot of eyes that have looked over these things, people doing security audits and things like that. So there is some level of inherent security there. And there's a community around open source projects, whether it be personal or professional interests for open source, that, like I said, you can kind of use that to your advantage also, whether you want to get involved or use that. Continue on, pros for choosing open source is transferable technical knowledge. Because it's an open source project, a lot of people have asked questions, a lot of people have gotten help, contributed to the project. These are things that are done out in the open that transfer across jobs. If you work on an open source project, it's not tied to that job, so when you leave there, people will still be able to see that work that you do. Cost flexible in that you can also you can save on costs because you can choose kind of which provider or places that you want to use with that service. And this also gives you a little bit of some platform flexibility. In case you want to change server providers or where you host this project, you have that option there. So there, like I said, there are some potential cons with using an open source solution or something that you have to host yourself. One of those is self-assembly. You have to find these projects, you have to get them running, get everything up and running. You may have multiple of these projects to where you need to re-implement these solutions because like I said, you're taking sort of ownership of that infrastructure there. And maintenance is also a side of that. Open source projects are continually being worked on or evolving and getting new features, so you may have some maintenance and upkeep there. In some solutions, they may just be maintained by a small number of people. There are, of course, big open source projects with a lot of contributors, and there are also ones that are dependent on by a lot of people, but are only maintained by maybe one or two people that maintain those projects in their spare time. So that could be a potential con there. But what we really want is kind of a mix between these two options. So the natural question to ask is, how can we have this balance of the pros of each approach, whether it be the pros of outsourcing and using open source projects? And that's where we want to get into that balance of what we need there. So some of the things that we're looking for with balance in open source versus outsourcing is ramp up time. You still want to be able to build and ship things quickly, depending on your team size. You still want a secure solution that has been looked over by lots of people. You still want an option that's scalable, whether you're just building for a side project, even on up to trying to build a company or business around this. You still want abstractions. Abstractions allow the project they can change the internals of it, but you may only use a certain part of it, or you take advantage of these SDKs that are out there to let you consume these services. And you still want something that's proven that's been worked on, like I said, over time, and has some credibility there. On the other side of that, you still want something that's managed. Not everyone wants to, run Linux on their home computer or have to, deal with the maintenance side of things. So you still want that option there. Still want ownership. Being able to own your data, like I said, pick up and move your data somewhere else, somewhere that may work better for your company or project at that particular point in time is a factor there. I also want that transferable technical knowledge that I spoke of earlier, to where, like I said, doing things out in the open allows you to take that knowledge that and apply it to other places. You still want the cost, flexibility of choosing your server or provider of choice, and the platform flexibility of, like I said, which platforms you can choose, which platforms you can target there. Because at the end of the day, we just want to get back to shipping the code, whether you're a developer, whether you're working in product or marketing or DevRel, you want to get back to that side of things and not having to keep making these decisions there. So one way, we kind of frame this around database. So one way to build around your database is with a REST API. So I'll cover what a REST API is, kind of the building blocks for REST APIs, and some features that if you were building your own REST API, because there's still scenarios where you might do this. So just in general, REST API stands for representational state transfer, and that's just what the REST is part of that. And API is application programming interface for, most commonly we call these RESTful APIs. And these are just APIs that you normally deal with, applications use these APIs to consume or provide and consume data. So if we look at the diagram here of a REST API, it's just something that sits in between your client and your server, or whatever the device is that's on your server, where the server has other data that you may need there. So what this can do is decouple your client and your server. For thinking of web applications, there's a handoff there. You send a request to the server, it sends you some data back, and that flow just continues to work that way. It's also stateless in that data isn't persisted across requests. REST API should, like I said, only handle that single request that was passed through. It's also layered in that these REST APIs are built up from many other systems that, like I said, built up to provide this data. And there's a bit of uniformity with REST APIs, that API requests, they should have, these resources should have a similar way to consume them, or a similar way they handle errors, or that they provide data back to the user in a structured way. So some essentials that you need for REST APIs. Of course, you need a server, because you need somewhere to run this thing. You can have your language of choice. As I mentioned before, there are many different options you can choose to write these APIs in. Also, common conventions for REST APIs for things like status codes, action methods, other pieces that you need to build the REST API. And of course, the functionality that you want to expose from your database where you're housing all this information. Also, you want your REST API could be a data abstraction. Most commonly, if you're building for the web, you're usually exposing some JSON data that consumers can use on the front-end application. Also, authentication, which is a very challenging thing to do. We have Auth0 here, and of course, that's what they specialize in. So authentication definitely plays a part in that. storage, whether it be storage and retrieval of files, images, or other things there, and connecting to other systems, whether this be underlying systems underneath, other services that REST API may talk to that you're kind of integrating with there. So that kind of brings me to AppWrite. AppWrite is an open source project. It's considered to be a backend as a service just because a lot of these things that are kind of talked about are wrapped up in there. Self-hosted. It's self-hosted in that you can take it and run it on your own infrastructure. Cloud-hosted version is on the way. So like I said, if you want to have more choice there, and it kind of wraps up some of these things I talked about with REST APIs, providing core functionality, and the community around a particular project. There's a big community around it. So just some information about their AppWrite just hit 1.0, so it's a big thing in open source. It's been in development for, I believe, over 3 years at this point, but finally reached the 1.0 milestone, so definitely proud of that. Contributors are, can be a sign of a healthy open source project. We have over 550 contributors. Forks means just anybody, a lot of people have forked the project, either take a look at it, run it on their own, and check it out. 10K GitHub commits, it's a really active project. A large developer community of people that have wanted to get involved, whether it be in different ways, and a Discord community there. So some of the things that AppWrite provides on the database side is, and some of these options were things I talked about earlier, whether it be MariaDB, which I said is a fork of MySQL, with support for MongoDB and coming soon in Postgres. And these are wrapped up in collections is what the primary thing is that you can use to, or like database tables, but with an abstraction on top for interacting with different databases. Another piece of this is authentication, and there, like I said, there are a number of different ways you can authenticate within your applications. So there's anonymous authentication, email and password, OAuth authentication, which is, I'd say, a more secure way of using that. There's also magic URLs where you've probably used this in the services before, where you want you to log in, but you don't have to enter using a password. They email you a link, and you click on that link, and it drops you in there. Or even just recently, just phone authentication, where you can integrate with some service like Twilio to be able to authenticate in that way. Also, storage adapters, when I talked about or hosting images or other data, whether it comes with file system storage. There's also integrates with different services like DigitalOcean or Amazon S3, Backblaze. These are just different providers that you can use that it has. There's also Linode for storage. One thing that I didn't talk about much was cloud functions, in that if you've used other services, I know that DigitalOcean has cloud functions, even like Firebase or other system like that lets you kind of offload data from your front-end app and run these kind of serverless functions. These are kind of self-hosted there, but it has runtimes for these cloud functions, whether it be Node, PHP, Python. Basically, you can pick the number of recent languages, and it probably has support for it in one way. But like I said, all these are in front of the REST API that AppWrite provides that you can talk to directly, or you can use one of these SDKs there. Real-time events. Like I said, if you have an application that's highly interactive and you want to send real-time events to the user, it allows you to do that with system events or database events. and like I mentioned before, with functions there. As I talked about abstractions for platform SDKs, whether it be web, server, or mobile, or Flutter, like I mentioned, these SDKs allow you to interact with Appright, let's say, as a self-hosted solution or a cloud solution there. So I will do a quick demo. I'm not going to live code anything because those things always have their own challenges. I will show Appright does run on the Docker, in Docker, and like I said, this is self-hosted, so the self-hosted option will always be there. So if you want to run Appright, you don't have to copy this code from here, of course. You can go to the website and find this code to run it on your machine. Of course, if you have Docker installed, but if you could fit it on a slide, you have to. So just wanted to show that there. And with that, I will switch over here to, this goes, okay, demo. Okay, so this is I already have Appright running on my local machine here, and it's just running on localhost. Hopefully everyone can see that okay. And so it's just a simple, this is just the Appright console itself. We have a to-do app that has a database and a collection of to-do items. And one of my to-do items is to speak at Refactor Check, of course. So like I said, the part about one thing about Appright that you can use is one of the JavaScript SDKs. So I have an application here where I can log into the to-do app, and I already mentioned running OpenSauce.pizza. Hopefully I get the login right here. There we go. Now LastPass. So like I said, this is a simple application. Everything is hosted in Appright. The authentication piece of it, I could connect this to real time. I already had this item here in my list. I could check that there because I could consider that to be done. If we switch over to the code here, we have, like I said, SDKs for web applications. Here I'm just using the JavaScript SDK to create a client and use the account information for logging in and the database for connecting to the database service, whether you have one or multiple. So it's just showing a quick way that you can integrate this in with your existing web application and use parts of it, or if you just want to use the authentication piece, you can use that, or use the rest of it there. So, like I said, quick demo for this to-do app. I do have a link to the app here. If you would like to view the source code for this demo application, you can go to this GitHub URL, and of course, you can see that after check it out later on, dig through it there. If you want to open the issue on the repo, feel free to do that too. I'm still building things open source, so I'm going to definitely continue to do that. So we talked about the open source balance with ramp up time, being secure and scalable, and having these abstractions and being proven. And the balance that we want with open source with also being managed, having an ownership of data, transferable technical knowledge, cost flexibility, and platform flexibility. So to recap the talk in general, talked about building products, the different solutions you can use there, decision factors in choosing an outsourced solution versus an open source solution. Talked about the pros and cons of outsourcing, and the pros and cons of using open source, REST APIs, and kind of a quick overview of kind of where Appright fits into this picture here. Thank you for the Refactor team for letting me give this talk. One last thing, I guess to slide back up here. If you want to learn, like I said, how to get involved in finding your next open source contribution, go to hiopensource.pizza, and it will show you some projects that are open source that you can try to find and contribute to. Thanks.
Are you taking questions?
Yes.
What do you consider an open source database that's hosted like on AWS or on Azure? Is that outsourced or open source?
I would still consider that to be outsourced because they're providing the infrastructure for you. You still have depends on how much access they give you to like connect to it and get your data out of it. So that would be, I would say, probably another good mix of that if you're fine with like I said, the other parts about it where they still host your data. At the end of the day, they can run other things on top of that. But yeah.
Yes. So are there, with this solution that you showed, is there limit to how many concurrent connections or limits of some sort? Because at some point, I imagine.
You mean current connections with like Appright or just in general? Oh, there aren't any. Well, I guess at some scale, you will maybe run into some bottlenecks depending on what your infrastructure looks like. Like the minimum requirements for running Appright is like 2 gigs of RAM and 2 gigs of RAM and 2 virtual CPUs, I believe. But the part about Appright is that you can. It's a Docker container that has a bunch of microservices underneath. So if you wanted to take like the database part of it, and like as you mentioned, use your MariaDB or MySQL database on something that is a lot larger than your self-hosted solution. So that could be one way you could scale out more. They have tested it, the real time. They have tested it in a couple of ways with, like, how would it work if you're, how would it work with storing like 1 million documents? That's one way it's been battle tested, or 1 million like web real-time, or 100,000 real-time connections, if I remember there's a blog post about it, but it does scale up incredibly well, even with this, even as it is just running it on pretty standard hardware. So, but like I said, you can use the database side of it. It uses the internal network by default, but if you wanted to separate that out to something that can scale up a lot higher, then you can do that too. Yes.
Just to add to that, if you don't want it to scale and you want to keep it small and simple, there's this other framework just like Appright called Pocket Base. It's written in Go. It's all in one binary, and it uses SQLite, which is right-hand logging mode, so it's insanely fast.
Yeah.
And it can scale to tens of thousands of connections on a solution.
Yeah, for sure. Yeah, that's a good point. There are other options out there for, like I said, self-hosted database solution. Appright is one of those. As you mentioned, DigitalOcean. You can deploy from Appright to DigitalOcean with a single click. So you can also have that solution where you're self-hosting, but you're not like setting up the servers and everything, because they already have like an image there. You can just take and get a production-ready system right out of the box there too. So I've also tried it with other hosting providers like Amazon EC2. You can run it there. I've also got it running on like Gitpod, which is like a ephemeral development environment. So it also works there too. Basically, anywhere you can run Docker Compose and you meet like the minimum system requirements, you can run Appright or even, like I said, one of these other solutions. So, yep. Any more questions? Cool. Thank you again.